I tried telling Dave Weiss, here's what I think he needs to say. And here's what you need to tell people. Let's just take the inverse square law of light, shall we? And let's talk about the sun. And Dave does this well, but I think he can change the math a little bit to make it even more explainable. Now let's all do it together. Think of the sun as big as they say it is, 867,000 miles wide. Okay, let's take that into account. Now, if it was 1 mile above our heads, what would the sky look like? We would look up and see what? Nothing but sun. The sun would take up everything that we can see. The entire sky would be sun. We agree? Great. Let's move that sun 93 million miles away. Now you can hold up a dime at arm's length and you can hide the sun. Okay? Remember, that's at 8 light minutes, 93 million miles. Let's double it. Take the sun, move it to 186 million miles. That little dot that's hid by the dime probably can now be hid by a pencil eraser, right? The sun is going to be extremely small, extremely tiny, and that's at 16 light minutes. Okay? Let's double it again. Now you've doubled the distance. Now we're at what? 186 times 2, so 360 something million miles. The sun is a tiny little prick, and now we're at a light half hour, right? Let's double it one more time. Now the sun, can you see it? Would you be able to see the sun? We just doubled it again, way far away, and with that double, we're at a light hour. Now let's multiply it by 20 fucking 4. Now let's multiply its distance 24 times. Now it's ludicrous that you'd be able to see the sun. Think of how small it got moving at 93 million miles, doubled it to get to 16 light minutes, doubled it to get to 32 light minutes, doubled it to get to a light hour. Okay, now we've times it by 24 to get to a light day. Now let's think, I don't know, why don't we multiply it by 365? Now it's 365 times further than it was. You think you'd be able to frickin' see the sun? Never. And that's a light day. Sorry, that's a light year at 365. Okay, and that's not even the closest star yet. Okay, so let's talk about the closest star. Closest star, they say 4 light years. Okay, if you don't know how to do the math on that, a light year is about 6 trillion miles. I know trillion is not a number that you understand. It's not a number any of us understand, but you take 6 trillion miles, multiply that by 4, and you get about 25 trillion miles. The closest star that there is, Proxima next to us or something. Now, think about this, okay? If we go 100,000 miles per hour, 100,000, which is insanely fast, faster than anybody's ever gone. It's about 70 times faster than a speeding bullet. Think how fast a bullet flies. Multiply that by 70, okay? That's insanity, and it's absurd. But let's pretend we're going 100,000 miles per hour. Great for us. Let me show you just so you can see that I'm not cheating on the calculator here. Oops. I need to do let's do a window capture and calculator. This one. And okay, pull it up. Here. There we go. Beautiful. Let's move this over here just so we can see this when we need it. There's our calculadora. All right. So now we've got, oops, move it a little more this way. All right. Thank you. That's a nice logo. Pretty. I like it. All right. So we got the calculator up. Now we said we were at 100,000 miles per hour. Okay. Easy math here. We're going 100,000 miles per hour, faster than anybody's gone. Think how fast that freaking craft is. Okay. And we got to get to the nearest star. Because why the fuck else are we checking it with telescopes? Why are we even worried about it? Why are we looking for exoplanets? Why are we talking about it? Why are we having press conferences about it? Because it better be attainable. Better be something that's not absurd. Okay? 100,000 miles per hour, and we go for a day. Nonstop, we don't eat, we don't drink, we don't piss, we don't shit. 2.4 million miles a day. Correct? Now we're going to multiply that by 365 because we want to see how far we go in a year. We go 876 million miles a year. Okay? That's if we're going 100,000 miles per hour. Fantastic. Sounds like fun. Now, we know that good old Proxima Centauri, 25 trillion miles away. Take that 25, make it a trillion, million, billion, trillion. Okay, 25 trillion miles. We're going to divide that by our 876 million, and this is going to tell us how many years it would take us to get to the closest star. Okay? And it would take 28,538 years. Get the fuck out.